Hello class. Now today I'm going to tell you why log base 10 is a special logarithm. Now for convention and for easiness for us, we define log of a as log base 10 of a. By the way, this is the defined symbol. It's basically an equal sign, but it argues that it is defined this way. It doesn't follow from an earlier proposition. So yeah, this is our convention that we use. Some textbooks I've seen use this notation to mean log base e to the a, but your textbook, you should look at your textbook obviously, which notation your textbook uses, but some more abstract mathematical literature uses log a with no base to mean log base e because it's a more convenient system to use for them, let's say. But for our intentions and purposes, log without a base means log base 10. So why is this so special? Now let's conduct an experiment, right? So what is the smallest possible number that has one digit? It is 1, and I'm disregarding 0 here for the sake of argument. So what is the smallest possible value that has 2 digits? Well, it's 10, 3, 100, 4, 1000, and so on. So a trend is in this data that, the smallest possible value of each digit number is a power of 10. And why is this the case, you ask? Well, we literally define numbers that way. I mean, think about it. I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I'm going to go to 10, right? All right, so I'm, switching up digits in the 10th place because I'm using a 10 decimal system. Then I'm going like 10, 20, 30, 40, whatever, and then 100 after 10 tens. So we have literally defined our system of numbers to repeat the previous amount of numbers 10 times to add one more digit. So what you're saying by the number of digits is how many times you have multiplied your number with 10 actually. That's why, that's where the 10 comes from. We literally define it to be that way. So what is logarithm? And I'm using this convention, 1. Well, it's 0. What is logarithm 10? Well, it's 1. What is logarithm 100? Well, it's 2, and so on. Now, you might actually assume that, for example, let's assume log of 55. What is it? Now, since logarithm is a continuous function, it's probably between log of 10 and log of 100, and it's increasing. So it's probably between 1 and 2, you might argue. So this is why we use base 10. It actually lets us decide the decimal numbers, the digit numbers of our numbers in a system. So if we use this system, what is 10? What is 1? Well, this is 10 to the power of 0, so that's why it's 0. What is 10? It's 10 to the power of 1, and this is 10 to the power of 2, and so on. Now, you might realize that the number of digits is always one more than the product that this logarithm gives you, is always log of x plus 1. And why is that the case? Well, because the power of 10 gives you how many zeros you have, but also you have a 1, which goes into here, 1 then follows the zeros. So that's why this formula makes even sense. And I will actually make it more conventional and say that the digit of a number x is equal to logarithm of x plus 1. But this will give you, for example, let us assume for the sake of argument that you are using 77. Well, log base 10 of 77 will give you something around 1 and 2, but then adding 1 will give you something around 2 and 3. But you cannot have like decimal places in digit numbers. I mean, they are supposed to be whole numbers, right? So what we do is truncating the number to the smallest integer that it is close to. So for example, if we are trying to determine what 7,894, like how many digits does this number have? Now, the digit of 7,894 is equal to logarithm 7,894 plus 1. So what is this logarithm between it? Now, I'm thinking that log base 1,000 is 3 and log base 10,000 is 4, so it's probably between 3 and 4. Between 3 and 4. So plus 1 will give you a number between 4 and 5. Therefore, you truncate the 5 and then you have 4. The fact is that this number has 4 digits, and if you count down 1, 2, 3, 4, of course it does. So that's why we use 10. It is because we literally define our systems to make log base 10 useful to us. Thank you for listening. I hope I see you in the next one.